Okay, after watching that other video, you should be able to fill in this little chart. So if we plug in -1 for x, we get -1 plus 2, which is 1, and the square root of 1 is just 1. 0 plus 2 is 2, and the square root of 2 is going to be a fun little decimal that you guys can figure out. 2 plus 2 is 4, and the square root of 4 is 2, and 7 plus 2 is 9, and the square root of 9 is 3. So when I plug these in, I get -1, 1, 2, 2, and 7, 3. So it kind of looks like this. So how can the inside of the radical be used to define the domain? Basically, what you need to know is that underneath part, that x plus 2, has to be greater than or equal to 0, because we can't have anything negative underneath that radical or we get an imaginary number. So in this case, our x has to be greater than or equal to -2. All right, let's go on. So here we are graphing radical functions. They are the inverses of power functions. We're going to talk about inverses later on in 5.6. And they are forms of the parent function, the nth root of x. And we've talked about like n being even and odd and what all of that means. So let's talk about what the parent function, square root of x, looks like. Remember that we don't include the negative values for x because they are imaginary. So I'm going to start at 0. If x is 0, then f of x or y is 0. Then I'm going to pick perfect squares for x. So because I want to take the square root of pretty numbers. 1, square root of 1 is 1. The square root of 4 is 2. 4, 2. Where am I going with that? Let's erase that weird little green dot I put right there. And I'm going to pick 9. The square root of 9 is 3. And then I'm not going to pick a fifth number because now I know that that's what that graph is going to look like. What you should also notice is that these square root functions look like half a parabola turned on its side. But the domain is 0 to infinity because we're not going anywhere over here. Whoops. I had a purpose there. Thought I changed it. We're not going over here in negative land because that's imaginary. And then our range is also 0 to infinity for these. And if you'll remember, when you think of square roots, they had a set range as well because they had those minimums where they couldn't go any further, like down. They were always positive. So square root functions, our domain has to make it so that radicand is positive. Okay, next we're going to talk about cube root. Negative numbers have cube roots. So I'm going to start with my first perfect cube over here, which is -1. The cube root of -1 is -1. The cube root of 0 is 0. And the cube root of 1 is 1. Now, in theory, we'd have -8 and 8 on this chart, but we don't. So we're just going to go with it here. But this looks like a cubic function turned on its side. Go out here to -2,8, +2,8. So that the domain and range are -infinity to infinity for these cube root functions, because remember, for a cubic, our domain and range were both infinite. All right. Also, I want to talk about really fast. I want you to make this note somewhere. To find the domain of a square root, set the part under the radical equal to 0. Okay, just write that down. We'll revisit that a little later. Okay, transformations. So this transformation out here, that k, moves us up and down. You guys know that, plus or minus k. So if we're going to go up, we're going to go up 4, and it's going to look exactly the same. Or we're going to go down 3, and again, we've got that nice down 3, up 4. This is horizontal. Remember that they are opposite of what you think they are. So this is a shift left and a shift right there with our 1. So right 1, left 6. Now, stretches do things a little bit weird. With a square root function, you want to remember that our parent function has these values. We've got 0, 0, then we're going to have 1, 1, and 4, 2, and 9, 3. So that A value, I'm going to zoom this out just a little bit. That A value is what we're going to multiply these Y's by. So this is a vertical stretch by 4 and a vertical compression by 1/2. So what we're going to do, and now I'm going to zoom in so you can actually see what I'm doing here. Leave that over there to the side. Is we're going to start at 0, 0. But where we would typically go up 1, like over 1, up 1, we're going to go over 1 and up 4. And where we'd go over 4 and up 2, we're going to go over 4 and up 8. So that it really stretches it so that that parabola is not quite so flat. And here with our 1/2, again, I'm going to change this into this pretty rainbow. Mark out our 4 here. We're going to multiply these by 1/2. So that where we start here at 0, 0, and then we go over 1, up 1, we're only going to go up 1/2. And we're going to go over 4, up 1, and over 9, up 3/2. So that it looks super, super flat compared to our parent function. Okay, reflections, easy enough. This is a reflection across the x-axis. Because guess what? Now all of our y's are going to be down here because we're going to find our square root and then we're going to make it negative. This is a reflection across the y-axis. So it actually looks like this, square root of y's. So again, just draw the sketches in your teeny tiny little boxes that you have there. I know you love me for that. So transformations of the cube root function. This one is going to go up 3, and we're going to stop there.